Okay, so today we're going to look at dividing polynomials and rational polynomials. And we're just going to jump right into it because there's not really that much difference between multiplying and dividing. The only difference is that when you divide, you change it to multiplying by the reciprocal. And we already knew this about fractions. So the steps are the same. If it's a polynomial, or if it's a binomial, a trinomial, or it's got more terms than that, we factor it, we mark out our factors, we come up with our answers. So when it comes to multiplying, then the only thing that we do differently is before we even factor it, we multiply by the reciprocal. So this x minus 1 over x squared minus 1 over x squared minus 4 becomes x squared minus 4 over x squared minus 1. So then we've got this problem, which we factor, and we factor, and we mark off factors, and we get an answer that looks like this. Again, make sure that we cross them off after we've already done the multiplication and the reciprocal, which is flipping the second fraction. So let's do a couple of these. And again, yep, you heard it. It's CUDA software, dividing rational expressions. I want to look at number 5. Notice that number 5 is a monomial divided by a monomial, which means that the first thing that I'm going to do is I'm going to write it as a multiplication problem. And instead of having that 6 over 9a, I'm going to write that as 9a over 6. And since there are no add or subtract signs, then I don't have to worry about factoring. I just need to go through and see if there's anything that I can reduce. Will that 7 go into either 18 or 60? Nope. That 9 has a possibility. 9 will go into 9 once, 9 will go into 18 twice. And the a. So I'm left with a 7 and a 2 and an a and a 6. And again, somebody might say, but I can do the 2 and the 6. No, you can't. The 2 and the 6 are both on the bottom of the fraction, and we can only reduce factors that are the same on the top and the bottom. So I'm left with a final answer of 7a over 12. Let's try it again. Number 9. I do see some add or subtract signs, so I'm going to go ahead and I'm going to just write some of the factors while I'm doing it. This one has a greatest common factor of 7a squared. So that's going to leave me with a plus 8. And I'm not going to write that as a divide sign. I'm going to write that as a multiply sign and put the 2 on the bottom. And the factors of a squared plus 7a minus 8 on the top. So it ends up looking like that when I get done multiplying. So let's see if there's anything we can cross off. This 7 will go with that 7. This a squared and that a squared. 2 minus 2 is 0. Anything to the 0 power is 1. So there's a 1 there. And then this a minus 1 is not going anywhere, but this a plus 8 has a possibility. So I'm left with a 1 on the top of that and a 1 on the bottom of that, and a minus 1 on the top of that, and a 2 on the bottom. So my final answer is a minus 1 over 2. On to the next sheet. And again, you'll notice there's not a lot of difference between what I'm doing on dividing and what I did on multiplying, except for the very first thing that I do is I try and flip that 2 put it on the bottom, and the 4b plus 10 I'm going to put on the top. So I'm going to go ahead and factor b squared minus 2b minus 15, and I'm going to get b minus 5 and b plus 3. Going to go ahead and factor 8b plus 20 and get 2b plus 5. And then I'm going to write that as a multiply sign, and the 2 is going to go on the bottom. I'm going to write that as 2b plus 5. Okay, so that problem has now become this one. All right, and let's see if there's anything we can cross off. The b minus 5s, no. The b plus 3, no. The 2, yeah, that one's gone. The 2b plus 5, yep, that one's gone. So I'm left with just b minus 5 times b plus 3 over 4. Last one to look at, number 22. Again, just going to try and go ahead and factor it a little bit as I'm rewriting it. That one doesn't have a greatest common factor, so that one's going to be 3x and an x. Trying to think of what one's going to work there. This is going to be a 3 and an x plus, no, a 9x. No, it's not going to be a 3, is it? It's going to be a 9 and a 3x plus 2. And that's going to be a multiplication sign. And then that's going to factor into 5x and x. And you'll notice that I'm sort of stopping here a little bit to see where the problem takes me, because I happen to know I'd be really happy if this problem would give me a 3x plus 2. So then I could mark it out. So then let's see whether or not we can make that work. That would be 27x, negative 27x plus 2x, so it does. And again, over here, I'd be really happy if this would give me a 5x minus 3. So I'm going to try it, and that would be x and 6. And let's see, that would be a negative sign in order to make it a positive 18. And that does work. So now what can I cross off? I can cross off these. I can cross off these. And so that leaves me with an x minus 9 there, and a 9 here, and an x minus 6 here, and a 1. Can I mark this off with that? Absolutely not. There's a negative sign and a subtract sign there. That's a no. You can't touch this without touching that. So my final answer would be x minus 9, x minus 6 over 9. Make sure you contact me if you're having trouble with this.